Good morning, everyone. In the last session, I discussed the types of machine learning. In that, we discussed supervised machine learning and unsupervised machine learning. Today, in this session, I'm going to discuss the other two types of machine learning, that is semi-supervised and reinforcement learning. Semi-supervised learning, it is a type of ML algorithm that lies between supervised and unsupervised machine learning. We know that supervised machine learning is going to use the labeled data set. Some supervision is required. Whereas unsupervised machine learning, there will be no labeled data set and there is no supervision is required. So coming to this semi-supervised machine learning, it is an intermediate ground between supervised, that is with the labeled trained data, and unsupervised learning with no labeled trained data algorithms, and uses the combination of both labeled and unlabeled data sets during the training period. Although semi-supervised learning is the middle ground between supervised and unsupervised learning and operates on the data that consists of few labels, mostly consists of unlabeled data. When you take a supervised machine learning, there will be some part of labeled data. Most of the part is unlabeled data. This is the diagrammatic representation. Here in this example, you can see this is the ML model. We are training with semi-supervised machine learning. In this, a small amount of labeled data set we are giving and large amount of unlabeled data set we are giving. And this ML model is going to give an output of pseudo labeled data set based on both labeled and unlabeled data set. And it is going to be trained on labeled plus pseudo labeled data set. And it is going to give you the results. To overcome the drawbacks of this supervised learning and unsupervised learning, the concept of semi-supervised learning is introduced. The main aim of this semi-supervised is to effectively use all the available data rather than only labeled data like in supervised learning. But in supervised, we only make use of labeled data set, but there is so much of data will be available which is unlabeled. So this supervised machine learning make use of those available data which will not only labeled. We can imagine these algorithms with an example. Supervised learning is where a student is under the supervision of instructor at home and college. Further, if the student is self-analyzing the same concept without any help from the instructor, it comes under supervised, unsupervised learning. Under semi-supervised learning, the same concept if we take the student under instructor and if it is self-analyzing, the student has to revise himself after analyzing the same concept under the guidance of an instructor at college. So it is a combination of both self-learning and there should be something from an instructor. That is what the difference between supervised, unsupervised and the semi-supervised machine learning. Advantages and disadvantages of semi-supervised machine learning. It is simple and easy to understand the algorithm of the semi-supervised machine learning. It is highly efficient and it is used to solve some drawbacks which we occur in supervised and unsupervised learning algorithm. Coming to the disadvantages, iteration results may not be stable. We cannot apply these algorithms to network level data. And coming to the accuracy point of view, it gives always less accuracy when compared with the existing machine learning, other types of machine learning algorithms. And the last type of machine learning is reinforcement learning. It works on a feedback-based process in which there will be an agent. An AI agent will be there. The agent is nothing but a software component. Automatically explore its surroundings by hitting and trial, taking some actions, learning from experiences, and it is going to improve its performance. It uses a hit and trial method, takes some actions, learns from past experiences, and improves its performance. That is what exactly how a reinforcement learning works. In this agent gets rewarded for each good action and get punished for each bad action. And hence the goal of RL, reinforcement learning agent, is to always maximize the rewards. In RL, in reinforcement learning, there is no labeled data like supervised learning and agents learn from their experiences only. There will be no labeled data set available. This reinforcement learning process is similar to a human being. For example, a child learns from various things by experiences in day-to-day life. An example of RL is to play a game, where game is the environment. When you see some online games, okay, where we have to first we are going to perceive the environment. Moves of an agent at each step defines the states, and the goal of agent is to get a high score. Why we play the online games? We will always play that to get an high score. That is maximizing the reward. And somewhere at some point we may get the punishment, and at some point we may get the rewards. These all these things terminologies comes under this reinforcement learning: states, agent, action, reward, punishment. Due to its way of working, this RL is employed in different fields such as game theory, operational research, information theory, and multi-agent systems. Real world use cases of reinforcement learning. The very much popular where RL has become is in video games. It is used to gain superhuman performance, and some popular games that use RL algorithms are AlphaGo and AlphaGo Zero. And other real world use cases is resource management, where with the deep reinforcement learning shows that how to use RL in computer to automatically learn and schedule resources to wait for different jobs in order to minimize the average job slowdown. And another use case is robotics. We know these days how popular these robotics applications are, and where we are going to use the robots in industrial manufacture area, and some at homes also we are going to use this robot for many things. Last one is the text mining. Text mining is one of the greatest applications of NLP and is now being implemented with the help of reinforcement learning, the uh, Salesforce company. Advantages of disadvantages of this reinforcement learning. Coming to advantages, it helps in solving complex real world problems which are difficult to be solved by general techniques. The learning model of RL is similar to learning of human beings, hence it gives them more accurate results and it helps in achieving long-term results. Disadvantage, RL algorithms are not preferred for simple problems. If there is a complication problem, then only complex problem, then only we are going to use this RL. Why? Because we need a huge amount of data. RL algorithms requires huge data and computation. Too much reinforcement learning can lead to an overload of states which can weaken the results. If too much RL you used for different state, which will weaken the results. These are the first category of machine learning, where supervised, unsupervised, semi-supervised, and reinforcement learning. There is another category of machine learning, that is batch and online learning. There is another category of machine learning, that is batch and online learning. In batch learning, the system is incapable of learning incrementally. That is, it must be trained using all the available data. Generally, this will take a lot of time and computing resources, and why? Because it is typically done offline. First the system should be trained, and it is launched into the production and runs without learning anyone. It just applies what it learned. This is called as the offline learning. This batch learning is also called as the offline learning. And if you wish a batch learning system to know about new data, let us say take that such a new type of spam. We have to train a new version of the system from scratch on the full data set. Then we have to stop the old system and it has to replace with the new one. And this obviously it takes whole process of training, evaluation, and launching an ML system. And automated fairly easily, even the batch learning system can adapt to change. And we have to update the data and train a new version of the system from scratch as often as needed. This solution is simple and works well fine with a full set of data if it is a small set. But if you think if it is a large set of data is there, so it takes the training, the full set of data takes many hours, and it may not be the always a best practice. So it takes training a new system, and we can train new system only every 24 hours or just weekly. And also training the full set of data requires a lot of computing resources like a CPU, memory space, disk space, network input output, etc. All these problems come across when you train the system with full of data. And if you have a lot of data and you automate your systems to train from scratch every day, it will end up costing you a lot of money. So if the amount of data is huge, and even it is impossible to use a batch learning system, then we have to find why, because it has limited resources. Then carrying around these large amounts of training data, taking a lot of resources to train for hours every day is like a showstopper. So a better option in all these cases, we discussed the problems with this batch learning, that are we should replace it with other algorithms that are capable of learning incrementally. That is what we come with the online learning. This online learning, we train the system incrementally by feeding it data instances sequentially, either individually or small groups. We call it as the mini batches. Each learning step is cheap and fast, so the system can learn about new data. And online learning is great for system that receives data as a continuous flow. You can take example of stock prices and needs to adapt to change rapidly or autonomously. And it is also a good option if we have limited computing resources, choosing an online system. And see this diagrammatic representation of our online system. If any new data is on the fly, it is going to learn and run, and it is going to evaluate this solution. And with the data, we are going to train the machine learning algorithm, which will automatically update online. Once an online system has learned about new data instances, it does not need them anymore. You can discard them. Even you can remove the data. So which results in a huge amount of space. And online learning algorithms may also be used to train system on huge data sets that cannot fit in one machine's main memory, which is called out of core learning. So this algorithm loads part of the data, runs a training step on the data, and repeat the process until it has run on all of the data. That is, just see the diagrammatic representation. When you have lots of data, where it is not going to fit into a machine, then this data is going to be chopped into pieces like this. It is going to chop it into pieces, and we are going to train this online machine learning algorithm. When you have identified a particular problem, you are going to train the online ML algorithm where we have a lots of data. It is going to chop into pieces, and we are going to train this online ML algorithm, and it is going to evaluate the solution. One important parameter of this online learning system is how fast they should adapt to changing data. When there is a change of data, how fast it is adapting to that changing data. So that is called as the learning rate. And if you set a high learning rate, then the system will rapidly adapt to new data. But it also will tend to quickly forget the old data. That if you set a high learning rate, then automatically it will adapt to new data. But at the same time, there is a chance it quickly forget the old data. And conversely, if you set a low learning rate, then the system will have more inertia, that is remains unchanged. That is, it will learn slowly, but it will also be less sensitive to noise in the new data or to sequences of non-representative data points. So a big challenge to overcome all these things, it's a big challenge with the online system, is that if bad data is fed to the system, if a bad data, then the system performance will gradually decline. So to reduce this risk, where there is a chances of noisy data or raw data, the data is not proper, we need to monitor the system closely and promptly switch learning off, and possibly we want to revert to a previous working state if you detect a drop in performance. When we see a drop in the performance of this machine learning online thing, we should always monitor the systems closely and promptly so that the challenges what we are facing with an online system can be easily reduced. Thank you.